Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's biweekly contest, number of black blocks. The problem states that you are given two integers m and n representing the dimensions of a m cross n grid. And you are also given a 2D integer matrix coordinates where coordinates of I represent a cell which is colored black. So all the cells which doesn't appears in coordinates of I are colored white, right? So a block is defined as a 2 cross 2 submatrix of the grid. More formally, like the block will start at x comma y. It will cover x plus y, x plus 1 y, x, y plus 1, and x plus 1, y plus 1. Basically, it's a 2 cross 2 grid which can be superimposed over the original grid. Now, you have to return a zero indexed array of size 5 where array I contains the number of blocks that contains exactly I black cells. So why size 5? Because the block size is 4. So at most the block can contain 4 black cells. So that's why you have to return how many blocks are there with 0 black cell, how many blocks are there with 1 black cell, 2 black cell, 3 black cell, and 4 black cell, right? So let's take an example. Let's say this is the matrix of size 3 cross 3, right? And in the coordinates it is given 0 comma 0. So basically only 0 comma 0 is painted black, all others are painted white. Now we have to find out the number of blocks which contain 0 number of black cells, number of blocks which contain 1 number of black cell, number of block which contain 2 number of black cell, and so on and so forth. So let's start with the this number of blocks that contain 0 number of black cells. So you can see this block of size 2 cross 2 contains 0 black cell. Similarly, this is another block that contains 0 black cells. And finally, this is one more block which contains 0 black cell and is of size 2 cross 2. So we found 3 blocks which contain 0 black cells. So the first output here is 3. Similarly, you will find one block which contain one black cell. This is the block which contain one black cell, and hence the output here is 1. So there is no other blocks possible, and hence everything else is 0, right? So hope the problem statement is clear. Now if you haven't tried solving it via brute force yet, I would strongly encourage you to pause and try to think of brute force solution and then move forward. So let's say this is the grid of size 4 cross 3, and the cells which are ticked are the black ones and all others are white. Now we have to count the number of grids or number of block which contain 0 black cell, 1 black cell, 2 black cell, 3 black cell, and 4 black cell. Basically we have to compute this particular array, right? Now we will we can start with this, right? This is the first block, this is the second block, third block, and then this is the fourth block, fifth block, and sixth block. Because we have to, because the block size is 2 cross 2, we can try iterating over every possible block, see how many black cells each of these block contain, and increment the answer accordingly. For example, we'll start with here. This is the first block, it contains one black cell, so we'll increment the count at 1. So this is 1, this is 2, this is 3, and this is 4, right? So we'll increment the count at 1. Similarly, we'll move to the second black cell, second block. It contains 2 black cells, so we'll increment the count at 2. Similarly, we'll move forward. It again contains 2 black cells, so we will increment the count at 2. We move here, it contains 1 black cell, to increment the count at 1. We move here, 1 black cell, and the final one contains 2 black cells. So previous one contained 1 and the final one contained 1. So this is the final output for this particular grid. So it contains 0 blocks which contain 0 black cell. It contains 3 blocks which contain 1 black cell. It contains 3 blocks which contain 2 black cell, and others are 0. Now what is the time complexity of this entire approach? Time complexity would simply be what you are doing. You are iterating over all the blocks, right? So how many blocks are there? So this is the last block possible, right? So how many starting points are there? Let's count that. So this is one starting point, this can be another one, this can be another one, this is another one, this is another one, this is another one. Basically there are total n minus 1 into m minus 1 starting points. So in total there are n cross m number of blocks, right? Like not n cross m, it is n minus 1 cross m minus 1, but this is the overall order of blocks. And now we will iterate over each of these, and in each of these what we are doing, we are iterating over all the cells to figure out which whether it contains black cells or not. So basically we are iterating over all the cells. So there are 4 cells in a block, so we'll iterate over 4 times. So this is the overall time complexity. Now this will not pass because the value of n and m both is 10 to the power 5. So this complexity would not work. We have to optimize this. Now what does optimization here means? Optimization here means basically we can't iterate over all the blocks one by one. That's what optimization means. Now you have to count the number of blocks, but you can't iterate over number of blocks. So it means you have to make some observation and think of a way where you will skip iterating over all the blocks, right? So here we'll look at the constraint, and constraint says that the coordinates length is 10 to the power 4. It means number of black cells in the block, a number of black cells in the grid is less than 10 to the power 4. So what we can do, we can simply try finding out the answer for 1 2 3 4. Basically we'll skip any block which have 0 black cell. We'll figure out the answer for 1 2 3 4, and finally we can subtract, like we can add them all up and then subtract it from the total number of blocks, and we'll get the answer for 0, right? So just to reiterate the like thought process, we figure out that n cross m is not possible, and it in turn means that you can't iterate over all the blocks. So we looked at the constraint. The constraint says that number of coordinates length is 10 to the power 4. It means we can iterate over all the black cells. So if we are iterating over black cells, if we can somehow compute the number of blocks with 1 black cell, with 2 black cell, 3 black cell and 4 black cell. Why we are skipping 0? Because we are iterating over black cells, so there will be at least 1 black cell in whichever block we consider, right? So that's why we will find out the number of blocks in 1 2 3 and 4, and finally to figure out the number of blocks which contain 0 black cell, we will add them all up and then subtract with the total number of blocks. What is the total number of blocks? As we figured out previously, total number of blocks is simply n minus 1 cross m minus 1, right? So let's look at or how to find out the number of blocks which contains 1 black cell, 2 3 and 4 without iterating over all the blocks. So this is the new problem. Let's say this is the grid now, 4 cross 4, and again this ticked ones are the black cells. So what we said is we can iterate over all the black cells. So notice this black cell. So this black cell can be present in a block which has this cell at 0 0, right? This can be one possible combination. This black cell can be present in a block where it is 0 comma 1, right? So we are looking at this black cell. So this is 0 comma 1 in this particular block, right? This cell can be a part of a block where this cell is at 1 comma 0, right? And similarly this cell can be a part of the block where this cell is at 1 comma 1. So these are the only 4 possibilities, right? So we will iterate over all these 4 possibilities and figure out how many black cells are there in each of these possibilities, and we'll simply increment the answer. So let's take an example. So as we said, let's start with this one first, right? Or let's start with this one only. So this is the first possible box or first possible block where this cell can be a part of. So this cell is a part of a block where this cell starts at 0 comma 0. Now how many number of black cells are there in this particular block? 2. So what you can say, okay, I found one block which contained 2 black cells. Good. Now this cell can be a part of block where this cell is at 0 comma 1, right? So how many black cells are there? 1. So you'll say, okay, I found one block which contain 1 black cell. Great. Now this cell can be a part of the block where this cell is at 1 comma 0. Now this block itself is not possible because it is the other two elements are not, they don't exist at all. So basically this block itself is not possible. So this is the end of this particular uh, cell, right? Now what else? So you can say, okay, let's start with this particular cell. Now again same thing, we'll start with the first block where this cell is at 0 comma 0. How many black cells are there? Four, like 2. So we'll simply increment the value here, right? Now this cell can be a part of a block which where this cell is at 0 comma 1, and again one black cell is there, so we'll increment 1, the value at 1. Now this cell is a part of a block which can contain this at 0 comma 1 comma 0. So again two black cells are there, so we'll increment here, right? Now this cell can be a part of this block where it is at 1 comma 1. So again two black cells are there, you can say, okay, let's increment it to 4. Now here is the difference. So notice that this particular block you have already considered before when you were tackling this particular cell, right? But now we have considered the same block while tackling another cell. So that's where what you can do, you can either apply a math and say that, okay, I know that every block of size 2 will appear twice here, and so I will like divide it by 2, something like that. Or you can say, okay, I will not apply any kind of math. Instead I can keep maintaining the actual cells which, or actual blocks which contributed to this particular number, and we can just take the distinct at the end, right? So these are two approaches. So let's discuss both of them one by one. So let's start with the current approach itself, where we are simply incrementing it, right? So we will increment it to 4, right, without worrying. Now this cell is done, so we'll start with the next one. So again the next one, there are 4 possible choice. Let's iterate over it quickly. This is not possible. This particular thing is possible, so it contains 2, so we'll increment uh, sorry, so we'll increment this particular thing to 5, right? Now this is not possible. This particular thing, it contains 2, and this is not possible, so we will simply increment here 1, right? Now finally there's one last cell, this particular thing. Here again what you can see is it contains one cell which is black, so we'll increment this particular thing, right? And then this is not possible at all. This is possible, so it contains again one cell, right? So we'll increment this to 4, right? What else? So like rest 2 is not possible, so we'll not do anything. Now what you can do is you can simply divide this 4 by 1, you can simply divide this 6 by 2, you can simply divide whatever is here by 3, simply divide whatever is here by 4, and that will be your answer. Now why divide by 2? Because you know that 2 black cells are there, so in each of these 2 black cells, this a single block will be contributed twice, right? So that's where we'll simply divide it by 2, and that will be the result. So number of cells that contains 0, like they contain one black cell is 4, that contains 2 black cell is 3, that contains 3 black cell is 0, and that contains 4 black cell is 0. Now how many cells are there, or how many blocks are there which contain 0 black cells? This will be 4 plus 3 plus 0 plus 0, which is 7, and you will subtract this 7 from the total number of blocks possible. So in this particular case, total number of blocks possible is n minus 1 cross n minus 1, which is 3 cross 3, 9. So 9 minus 7 is 2. So this will be the final answer, right? So this is one possible way wherein you are trying to apply some mathematics to figure out to remove the duplicates, right? Another simple way could be to not do any kind of mathematics. Instead, just maintain the duplicates as well. So let's just instead of a single array, you will maintain a 2D array, and you will keep on maintaining the actual positions of the blocks as well. So let's just iterate over it one last time. So again, we'll start with this. This is the first block. In this particular block, you'll say, okay, I found a block which contain two black cells, and the block starts at 0, 1. So instead of just incrementing the count, you are now maintaining 0, 1 as well, right? Similarly, let's say, similarly, you'll say, okay, I found one one block which contain one black cell, and the cell and the block starts at 0, 0. So instead of maintaining just 1, you are maintaining 0, 0, right? Similarly, the other two is not possible here. So let's move forward with the next one. So let's say this one, right? Again, the same thing. You will say this is the first one. So again, you'll say I found one block which contain two black cells, and it starts at 1, 2. So you will do this, right? Now this part, again, one, it contains one black cell and it starts at 1, 1. So this particular thing, right? And this one again, you will say I found one block which contain two black cells, and it starts at 0, 1. So because it is already present, you will not include it again, right? So that's how you are trying to avoid duplicates. In the previous approach, we have avoided duplicates by doing simple maths, and in this particular approach, we have avoid duplicates by maintaining the actual start position of every block, right? So you will keep on doing this. You finally get this particular 2D array, and you can simply count the number of distinct elements in each of these positions to get the number of blocks which contain one black cell, two black cell, three black cell, and four black cell. And finally, you will sum them all up and subtract it from the total number of cells to get the number of blocks which contain zero black cells, right? So what is the overall time complexity of both the approaches? In the previous approach, we will just iterate over every black cell 4 number of times. So it will be 4 into number of black cells. The previous one where we applied mathematics. In this particular approach, we are iterating over the exact same thing, and we are storing the positions as well. So the previous approach had time complexity of 4 into b with a space complexity of order 1, right? But this particular approach of avoiding duplicates has time complexity of 4 into b, but the space complexity can also go up to 4 into b, right? So hope both the approaches is clear. I would strongly encourage you to pause the video and try to code both the approaches by yourself. They are pretty straightforward. So next we'll be looking at the code for this particular approach, because the first approach is very straightforward, right? And you can like, if you know how to code this, you can simply code the other one as well. So the code is straightforward. What we are doing is we have maintained a set of all the black cells so that we can easily do lookups. So why this is required? Notice that when you are looking at a particular block, you need to figure out how many black cells are there. So you have to find a way to figure out whether this is a black cell, whether this is a black cell, whether this is a black cell. So that's where this set will help. So we have maintained a set where we have inserted all the black cells. After that, what we have done, we will simply iterate over all the black cells. Now for each black cell, there are 4 possible blocks that can contain this particular cell. So we'll iterate over all the 4 blocks one by one, and for each of these blocks we need to count the number of cells, and some of this block may not be valid, so we need to also make sure if the block is valid or not. If the block is not valid, we will not do anything. If the block is valid, we will simply insert the top left cell of the current block in the number of black cells, right? Now after we have done this, we'll simply iterate over all the all the cells which have at least one black cell, so 1, 2, 3, and 4. That the value of them would simply be cells of I dot size, because this cells is a set, so this will only contain unique positions. So we'll simply know the answer for each I from 1 to 4, and for 0, as we have discussed, we will simply figure out the total number of cells and subtract everything from that, right? Now finally we need to now look at iterating over all the cells of a particular block. So that we have achieved through by maintaining a array initially. So this is like all the cells if you start at 0 comma 0, or if current block start at 0 comma 0, all the positions if current block start at 0 comma 1, and so on and so forth. So you maintain this. Now inside this we are iterating over all of this of the ith position. So basically it has four things, right? If the current cell is 0 comma 0, if the current cell is 0 comma 1, and so on and so forth. So we'll, for each of them we will iterate over all the possible cells. So we'll figure out all the possible cells. It can happen that the current cell is not valid. For example, if you have considered this particular block, so you may reach at these two cells which are not valid. If you reach there, we will simply say that it is not a valid position, and we'll break out from the loop. If not, we will simply query is present structure to figure out whether it is a black cell or not. If it is a black cell, we'll increment the count. So hope this entire solution makes sense. If you have any doubts in this particular problem or in any of the approach, feel free to post them in the comment section below. I will be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.